All right, physics friends, welcome back. Today we're going to look at a different problem. We're going to look at problem number 2, when a box is sliding on a rough incline. So here's our setup. I've got a box, and it's sliding down a rough incline where the coefficient of kinetic friction is 0.04. Remember, kinetic means motion, so it's in motion. The angle of the incline is 45 degrees, and the length of the incline is 3 meters. Now the box starts from rest at the top. Okay? So at this particular instant where it's drawn, it's already in motion. And I've drawn the free body diagram. So I've got the weight pointing straight down, the normal force perpendicular, friction pointing up the incline because the box is going to slide down the incline. And then I have the components FGX and FGY of the weight. Okay. Now I'm interested to know how long it actually takes the box to travel the full 3 meters on the incline. Now how long, if you remember this is code, how long is code for time? Okay. Now time, how do I find time? Well, kinematics is how I'm going to find time. So kinematics is how I'm going to find time. But in order to use kinematics, I need to find the acceleration of the box first. Okay? Because I know it's on an incline, I know it's going to accelerate. And so it's going to accelerate. I need that for kinematics. So I can't use kinematics to find the acceleration. And in this case, I'm going to have to use F net equals ma. All right. So let's get started. All right. So I have in the x direction, because that's the direction I'm going, down the incline, I have F net is equal to ma. And remember, F net is helping forces minus hindering forces. Okay? Helping forces point in the direction of motion. So if I take a look at my free body diagram and my direction arrow, the helping forces would be FGX. Okay? So I have FGX, helping. And the hindering forces would be parallel to the direction of motion, but pointed in the opposite direction. And that would be my friction. So I have FGX minus friction equals ma. Okay. Now I'm going to expand those terms to figure out what we need to solve for. Now remember, FGX is the x component of the weight, and if this is my theta here, it's sine because it's the opposite side. So it's going to be Fg times the sine of theta. And I can write friction as mu, the coefficient of kinetic friction, times the normal force. So this is mu Fn equals ma. Okay. Now, I don't know what Fn is, and I don't have Fg, but I'm going to keep going. I'm not going to get stuck. I'm going to expand these things, because I can write them as other things. So Fg, I can write as mg, mass, times the acceleration of gravity of wherever you are, times the sine of theta, minus mu. Now, looking at my free body diagram, what is it that Fn is equal to? Well, Fn, if you remember from the intro lesson, is directly across from the y component of the weight. So Fn and Fg are equal in size, and opposite in direction. So I can find Fgy by using trig. Now, it's the adjacent side to the angle, so I would need to use cosine to figure that out. So it's going to be the hypotenuse, cosine times the hypotenuse of the triangle, which is Fg. So this is mu Fg cos theta is equal to ma. Okay. And now Fg I can write as mg. It's the same block. So I have mg sine theta minus mu mg cos theta is equal to ma. Okay. Now again, I don't have the mass, but again, it didn't give it to me, so there must be some magic that's going to happen. Now I want to solve for acceleration before I move into kinematics, so I'm going to divide by m on both sides of my equation. And because mass is in each term, there's a mass here and a mass here, I can drop mass out of my equation altogether. Okay? And so I'm left with g sine theta minus mu g cos theta is equal to the acceleration. Now, if you want to simplify this further, you could pull g out as a common factor, but you don't have to. We're just going to do the math from here on out. So this is 9.8 times the sine of 45 degrees minus 0.4 times 9.8 times the cos of 45 degrees is equal to A. And so this term, 9.8 times the sine of 45, that's 6.9. I'm just rounding to one decimal here. And this multiplication is minus 2.8, and that equals your acceleration, which is equal to 4.1 meters per second squared. Cool, but I'm not done yet because that's just the acceleration. And what did the problem want? It wants time. So now I can go over to kinematics and I can plug in my given chart. It's only one direction, which is nice because it's only in the x direction. It's not moving in the y direction because remember we orient our axes so that the x direction is down the incline. So I have x's here and then I have all my variables, v, v naught, a, t, s, and s naught. Okay, so A is 4.1 meters per second squared. The problem tells me it starts from rest, so V naught is 0. Time is what I'm looking for, that's my question mark. S is how far it travels, and so that's the length of the board, that's the 3 meters. And S naught is 0, because it starts from 0. Okay. So now we need to just pick the right equation and figure out where we're going to go from there. All right, well I want time. So remember your kinematic equations, you have V is equal to V naught plus AT. You have S is equal to S naught plus V naught T plus 1/2 AT squared. And you have V squared is equal to V naught squared plus 2A delta S. Well, the third equation is out because that doesn't even have time in it. And the first equation I can't use because I don't know the final velocity down here at the bottom. Okay? And I can't just use the average to figure out what that is because at this instant in time, it's not the average velocity. So I'm left with the second equation. All right, so I have S is equal to S naught plus V naught T plus 1/2 AT squared. Okay? And I'm looking for T. Now, what's cool here is that the initial velocity is 0, so this whole middle term goes to 0. And S naught is 0, so that drops out. So I'm left with S is equal to 1/2 AT squared. Well, that's nice and simple. S is 3 meters, 1/2 A is 4.1, and then T squared. So if I multiply both sides by 2 to get the half out, I get 6 is equal to 4.1 T squared. And then dividing by 4.1 leaves me with 1.46 is equal to T squared. And then the last thing I need to do, don't forget, you need to take the square root because you have a T squared. So the square root of 1.46 is 1.2 seconds. Right? And that is your final answer. So this could be modified in lots of different ways. You know, your teacher might say, well, how long does it take to go halfway down the board, or what's its speed at the end, or how fast is it going halfway in between, all sorts of variations. But this is the basic setup. Okay, so I hope that was a little helpful, and hopefully I'll see you in the next video.